Hello everyone. So today I'll be solving a reverse engineering challenge named Deja from the Anveshanam CTF. So let's dive into the challenge directly. So here we have a user.out file that was given in the challenge. Okay, and if we check the file type, it is a 64-bit LSB by executable and it is a non-stripped binary. So if we run it, we can see that it is asking for a password. Let's say enter a random password, and on entering a random password it says welcome, fail, try again. So basically we need to get the password so that we will be able to get the flag. So let's perform some basic analysis on this binary first. Let's check out the string if there is something interesting in it. Okay, so we can see the strings over here. Fail, try again, password correct. Okay, and there's some gibberish strings. So I'll open the binary directly in Deja. Let's fire up Deja and open the binary init. If you open the binary first time, then you need to create a project and then you need to analyze that binary so that it will detect all the functions. Yeah, so this is the decompiled view of the main function. On opening the binary first time, you can open the this decompiled view of the main function from here directly. You'll be able to see all the functions in this function listing here. On clicking on main function, you can see the decompiled view of the main function. Okay, so let's analyze this C code. If we see, here it is asking for a password. We need to enter a password, taking the input, and then it is initializing a variable, and it is performing some operations on our input. Okay, and it is then saving it to this variable, and after that, it is checking with this initialized variable and our input whether it is equal or not. And if it is equal, then it enters this if block, it says password correct and prints us the flag. So most probably this must be the flag over here. And it is printing it here in this statement. So if we see, here we have three approaches to solve this challenge. First is to reverse this code and get the actual password so that we can enter the password over here when we run the binary. And after entering the password, if our password is correct, then it will enter this if block directly. It will say password correct and it will get us a flag. The second approach can be to reverse this operation. We have this string over here. We have this hexadecimal strings over here. If we hover over it, we can see the character array values. See, actually here, if we see where it is called referencing this variable. So actually this is a complete single string. In Deja, it can store only 8 bytes at a time in a variable. So it is basically splitting the string into multiple variables. So this is actually a single string which it is storing in multiple variables because Deja can store 8 bytes at a time. Okay. So the second approach can be to convert this into strings, and as this is a little endian format, so we first need to convert each of the variable into string, and then reverse each of the strings and then concatenate them and then perform this operation, this for loop over here, whatever it is doing, like it is starting from first index to the last index of the string, and then it is subtracting 4 from each of the characters. Okay, so this is the second approach. And third approach can be, we can use a debugger tool and just skip this check. We can skip this check and directly enter this for loop, and we can set a breakpoint here, and we can directly print out the value here without doing any kind of reversing. So I'll first of all go with the third approach that I just now told. So let's continue with it. Let's open debugger. So I'd also suggest you to use PondDBG because it gives a lot more information as compared to GDB. Okay, you can install it using the Python library. You can check it online. Okay, so let's dive into the challenge. If we see, let's check out the functions. We have the main function over here, which is starting from this address. Okay, so now we can disassemble this main function. I'll not disassemble it completely. Let's disassemble some of its instructions. Let's say I want to disassemble 100 instructions of the main function. Now we need to set two breakpoints here. First of all, would be at this so that we can skip this check and directly enter into the if statement of this code. And the second breakpoint will be in this print statement so that we can get the value, whatever it is printing over here. So we need to find the address. Okay. So in the left side of this disassembly view, you can see the assembly code. So if we click on this variable, you can see the address over here where it is checking. This is the assembly code jump not 0. So here it is checking if the if this value is not equals to 0, then it will jump to this else block where it will print fail try again. See, if we click on this jump not 0, it is going to this, and here we can see it is printing fail try again. Okay, so the address basically what we need to so we need to set a breakpoint at this address jump not 0. Okay, so the address is 1466. Let's find the address. Okay, I guess I need to print some more instructions. Yeah, so the address was 1466. So this is the address, and so I'll set a breakpoint here 605. Yeah, so we have set our first breakpoint, and I'll set the second breakpoint at the print function. Okay, so the print function is at address 1530. We'll find the instruction first. Yeah, so we'll set the breakpoint at here, main plus 807. Okay. So we have set the breakpoint. Set two breakpoints if we see. Yeah, we have set two breakpoints at these two different addresses. Now we can just run the binary. It is prompting us for a password. Let's enter a random password. And if we see, it has stopped the execution over here at this instruction where it is checking jump if it is not equals to 0. So it will only jump if it is not equals to 0. So we need to set the 0 flag so that it doesn't jump and it enters into the if block. Okay. So here we can see it is if here as the password is not correct. So here the condition becomes true and it enters, and on the next instruction, it is entering the else block and it will print fail try again. So we will need to set the 0 flag to 1 so that it will not jump. Okay, so how we can do that? Let's check the register first on which we have the 0 flag. So yeah, here we can see the 0 flag is not set. So in the E flags register, the 0 flag is at the 6th bit. Okay. Listen carefully. In the 0 flag, in the E flags register, the 0 flag is at the 6th bit. Each register consists of 8 bits. So, and the 0 flag is at the 6th bit. So we need to set the 6th bit to 1. So how we can do that? If we set the, let's say, I'll show it to you. We need to set the 6th bit to 1. That is, it should be in binary, it should be like this 0, 1, and after this, 5 succeeding zeros. Okay. Yeah. So this should be the value 0, 1, 2, 3, 4, 5, 6, sorry, 7, 8. 1, 2, 3, 4, 5, 6. Sorry. 0, 1, 2, 3, 4, 5, 6, 1 more 0. 7. So here are 7 bits, sorry, 8 bits starting from the 0th index. So we need to set the 6th bit to 1. And if we convert this binary into decimal, it will be 64. And in hexadecimal, it will be 40. You can check it out as this. Yeah, in decimal, it is 64. And in binary, it is 40. We can remove the 0 B here. Yeah. So this is the binary value. So we need to set the 6th bit to 1. So how we can do that? We can simply just use set e flags is equals to, and we will do an OR operation with this hexadecimal value 40. Okay. So now if we see the register e flags, we can see the 0 flag is set. Now we will go to the next instruction. We can go to the next instruction using this NI. Okay. I'll lower down it a bit. And now we can see we have entered the if block. Here it says password correct. Okay. So now we will continue executing the program so that it will stop the execution over here in the print statement. Okay. So we can continue the execution just by entering C and enter. So yeah, here we can see it stopped at this print function main plus 807 where we set our second breakpoint. So this is a flag what we need to get. So this is the first approach. We have got the flag, and this is a flag in the UUID format. And after and we can enter this flag in the curly braces like this flag curly braces and this input. Okay. So this is the first approach. I'll show you one more approach. You can do it manually like this with the and you have to do a little bit of reversing in it. Let's go to Deja. Where is it? Yeah. Okay. I'll go to the main function. Now we can see that we have the strings over here, but it is an hexadecimal value and it is performing some operation over it. I've already explained this operation, what it is doing. So what we can do is we can unhex these values and we can concatenate all these strings together and then perform this value and perform this operation. Okay. So if you do that, let's see. Yeah. So this is our first value. I'll try to do it faster. So this is our first string over here. And let's say we can store it as string. We need to reverse it too because in Deja it represents a hexadecimal in Little Indian format. Okay. So we will reverse it as now. We'll copy the second one. Annex it. Sorry. You can do this operation by yourself. I'll pause the video for now so that I complete these operations. This is the same thing that I'll be doing with rest of the strings. So yeah, this is our string. I performed all the necessary operations, unhexed it, reversed it, and then concatenated it. If you check the length of the string, yeah, 36. So now we need to perform this operation. It is a simple for loop. It is subtracting 4 from each of the characters. You can achieve it using Python 2. Let's see, we have the flag as empty string, and let's run a loop. Flag plus equals to, and then we need to convert the first convert the characters into its as into the integer value. Okay, so for it, and then subtract it, and then we need to change it character again. Okay. So yeah, now if we print the flag, so yeah, this was our flag. This was the flag that we got from here. See, both are same. So these were the two approaches from which you can solve. I guess the first one was much more easier if you are able to use font debugger, and the second one you needed to do a little bit of reversing. You can also reverse this portion over here so that you can get the actual password, and then you would be able to get the flag. So I hope you were able to understand it very clearly, and let's meet in the next video with another exciting challenge. Okay.